This meeting is being recorded.
So, welcome to today's Tech Hour. It's Thursday, the 10th of November, and we have two speakers. The theme is archive access for the first speaker and the TeX Macro Store for the second speaker. The first speaker is Shamji Brin, who is User Experience Manager at arXiv and is leading user research that will guide their accessibility efforts. The second speaker is me. I'm retired, and I'm going to talk about the TeX Macro Store, which is a sneak preview of software that's in progress. So without further ado, over to Shamsi.
Great. All right, I'm going to share my screen. I can't share my screen.
Okay, so sorry. Participants more. If I make a co-host, you ought to be able to share your screen.
That worked.
Is that working? Does that work, Shamsi?
Yes, I think that is working. Just finding the right window. Okay.
Excellent.
That looks like the right window. All right. Well, thank you very much for letting me share this presentation from arXiv. I'm really happy to share the info that we've been getting from our users around making research papers accessible. And in this presentation, we can also share the role that we've learned that arXiv can play in improving accessibility. So first of all, arXiv is the world's largest preprint server. We host over 2 million paywall-free research articles, and this number grows every day from scientists all around the world. And of interest for this community, 90% of the submissions that we receive come in LaTeX form. So whenever we talk about accessibility of research at arXiv, we are inevitably going to have a conversation about TeX as well. So arXiv has been overcoming access barriers for over 30 years, which we're very proud of. And this work is very, very important to the open access movement. But before we get too complacent, just access is not enough. Accessibility is what ensures access regardless of disability. And this problem, of course, is bigger than arXiv. If you have a reading disability, then gaining access to the research in your field is at best difficult and inefficient, and at worst, it can be impossible. So when we at arXiv say that arXiv is open, we have to ask, open to whom? So we recently completed some intensive user research with over 40 members of the arXiv community, and this included scientists who rely on assistive technology, research experts in accessibility, and many more. And we asked about their experiences accessing research on arXiv and beyond, because we're part of an ecosystem. And this chart that I'm showing here shows the positive versus negative experiences that people have at 5 critical steps when they're accessing research. So we have finding research, reading that research, participating in scholarship in general, preparing documents, and submitting documents. This chart is also available in an accessible table format, which I can share in just a little bit. So as you can see in this chart from the red bars, most experiences with access that people have are negative at most of the steps. Some of the most critical barriers that we heard about are math, figures, and charts frequently being unreadable to screen readers. And we also heard feedback on the difficulty that authors have making their papers accessible, even when they want to. So we are not doing well in ensuring access to research for people with disabilities. Accessibility is the next frontier for access. Researchers and practitioners in STEM who have disabilities have been advocating for truly open access to research for a very long time. But what we heard is that not a lot of progress has been made. A question that often comes up in this topic is how many people are affected? And first, we strenuously hold that everybody should have access to scientific research. We should not only think about the majority group. But that said, the answer is that a lot of people are affected by inaccessible content. A significant portion of people have disabilities that affect their access to research or even their ability to enter STEM fields in the first place. If science is to reach its fullest potential, we need wide and diverse participation. What we've heard through our years of research is that it's really important to our community that arXiv be as open as possible to as many people as possible. So where do we get started? To address the many varied disabilities and barriers to access, we need flexible content. So researchers need to be able to approach research content in the way that works best for them. Also, math, it must be accessible to screen readers, and figures and other purely visual content need accompanying text descriptions. After surveying and interviewing our community, our participants told us what this means for arXiv, that we need to offer accessible HTML formatted papers alongside existing PDF and TeX formats that arXiv already has available. The flexibility that HTML provides is more than just access. It also gets us a step closer to equitable access. And this is one example that we heard. If you don't want to read through a paper from start to finish, or if you're not sure yet if you want to read through that paper, then you skim it. But to skim with a screen reader, you rely on the semantic formatting like headers and sections to navigate. And without those tags, without that semantic formatting, you can't skim. You can't leap to the content that you need. The vast majority of PDFs do not have those tags. Well-formatted HTML will get us one step closer to a more equitable experience, while also ensuring basic access. So making research accessible is this huge, exciting, important, and really big challenge. It will take the entire scientific community working together to truly transform our scientific fields and make them fully accessible to everybody. But we heard from our community that arXiv has a role to play now and can have immediate and positive impact. And these are our strengths, that authors have a close relationship with the arXiv platform, and it's a good place to learn how to make your document more accessible. And most of these documents are LaTeX, 90%. We control the submission pipeline, and we can implement positive changes like generating HTML. And we can request that the author inspect that HTML output right then while they're submitting, and we can provide them with feedback on accessibility. And because arXiv covers many fields, the changes we make will have broad impact, greater than a single journal or single conference could have. During our user research, we heard over and over that providing HTML is the right direction for arXiv, and it's the most important role that we can play. So our immediate path is clear. It's not easy, but we believe it is achievable to provide HTML output during submission. Because this change is so practical and because it's immediately impactful to authors, we can use that effort to shed further light on accessibility and the need to rethink how research is shared in general. The needs of researchers with disabilities have been ignored for too long, to the detriment of the scientific world. though complete accessibility of scientific fields is much larger than arXiv, by providing HTML alongside existing formats, immediate and impactful change is within our reach. So a really special thing at arXiv is that the scientific community has put its trust in arXiv for over 30 years. arXiv really belongs to the scientific communities that it serves. And this level of trust gives arXiv an opportunity and also a responsibility to make the research that we host as open and as accessible as we can. So shortly, we're going to be sharing our plan, our public plan for making the papers that we host more accessible, and with the purpose of raising awareness, building support, and securing funding for this important work ahead. And your vocal support for making research papers accessible to everybody can help move the needle. So please keep an eye out for that announcement on our blog, on Twitter, other channels. Please share it with your colleagues, and please join the conversation, join it loudly. The next logical step for open access is to embrace accessibility and ensure research is truly open to everybody. Thank you so much.
Thank you very much for that presentation, Shamsi. It was lovely. And I was very pleased to hear that the arXiv is picking up accessibility, because it's a real opportunity for us, I think. Paul Ginsberg, when he had such a large role in setting up the arXiv, saw that there was an opportunity that LaTeX provided. LaTeX provided an opportunity. And seeing that opportunity and single-mindedly pursuing it was a great thing. The opportunity now goes to the other way, that your accessibility initiative is an opportunity for the tech and LaTeX community. So I'm very pleased to see this, and I support what you're doing.
Thank you. I'm happy to answer questions if there are any. And I just shared a link in the chat that I had mentioned during the presentation to an accessible version of the chart that I had showed earlier. And we're also open to questions or thoughts anytime. Oh, Kaveh.
Yes, if I may also, because thank you, Shamsi. There's not much to argue in there. Of course, we all agree. And what a job. You've got 2 million papers, and we need to make them accessible. I've got a few questions. Let me, firstly, you mentioned HTML several times. So that seems to be the way to go, right? HTML to be accessible, rather than accessible PDF, say.
Yeah, we could share a little more about that. So what we clearly heard through the user research is go the HTML route. Don't just try to remediate PDF. That isn't good enough is essentially what we heard from our users. And there's benefits that you get from HTML that you just can't get from PDF. But that said, the LaTeX core group is working on producing accessible PDFs from LaTeX, and when they have that work ready, arXiv will incorporate it as soon as we can. So we would like to make progress on as many accessible fronts as we can, including more accessible PDF. But we won't wait for that. We'll work on this HTML stream. Okay,
if I get immediate question after that, you have, of course, the R5 HTML version. What does that go any way towards accessibility, or can you work with that, or is it going to be a new project?
So R5 is the LaTeX ML group, and we are hoping to work with them very closely. That's something that Charles, our CTO, is working on the details. So that will be hopefully part of the plan that we'll be sharing publicly. And I know that Charles will be welcoming public feedback. He'll be sharing our thoughts and in a more technical way what we're going to be working on, and he'll be welcoming feedback from the public. but I believe the LaTeX ML project will be very important to archives work.
Hello, can you hear me?
Yes.
Oh, thank you very much for your presentation, and sorry for my poor English. When I realized it was possible to download the LaTeX source on arXiv, it really changed my life before. Because before with a PDF, I need human aid, but with a LaTeX source, everything is okay for me for mathematical papers. So please keep on providing the LaTeX source for all papers. It's really great. I just mentioned problem for me. It's very difficult to search for a particular paper. Before there was something called front for the archive or something like that, front of a website where I could easily search for a paper. But now it doesn't work anymore, so it's too bad.
Okay, interesting. So do you, David, is the archive front, is that mathematics?
Yes, there was an individual maintaining this for mathematics, and there was a system problem. They had a problem. It's like it operates similar to a mirror. We basically mirror all our files to his system, but his software had issues with some upgrades we made, and he did not have time to fix his system. So it basically has kind of gone away. And I'm not clear whether he will attempt to revive it. I think it's been gone for a few years now.
Well, it's too bad because search is really a problem for me. There are too many things I think on the page. Like often, it's because of that it's difficult to search, and one is blind.
Conrad, I was just going to ask you. So you have a visual disability, is that correct?
Yes. I'm almost totally blind because of glaucoma.
Okay, okay. And may I ask, please? So you're saying that when you have the source, you have the LaTeX file, and how good is that for?
When I have the source, everything is okay. So the problem with mathematical research for me is that journals editors do not want, I don't know why, to provide LaTeX source, even for people with disabilities. It's really too bad because PDF is not accessible. Mathematical formulas are not accessible. So, but with LaTeX source, everything is okay. I can analyze the paper completely because LaTeX is one-dimensional. I think that's the point. So it's great for blind people, LaTeX. Thank you, Donald Knuth, for that.
Certainly, I can just reassure you that arXiv will always have the TeX source available.
Oh, great! Because I had a correspondence with one from arXiv, and he told me that before it was mandatory, necessary to give the LaTeX source, but now there are some papers who do not provide a LaTeX source. I think it's really too bad.
So almost all papers are still required.
But why not all?
There are a few exceptions, and I wonder if David could speak to those exceptions a little bit. And then I also see that that Paolo has raised his hand, but maybe David could speak to where those rare exceptions come into play.
I'm sorry, could you repeat that, the question?
The question was, why isn't everyone required to provide TeX source when they submit to arXiv?
Okay, so we have to be able to compile the TeX source. So there are many flavors of TeX, and when we encounter a submission that we can't compile with the local system, the admins will grant an exception, and they'll allow them to submit a PDF. And I have been trying to modify that and get them to include the source with that, but I haven't won over that battle yet. So, because it'd be worth having it so that, I mean, someone else may have the appropriate tech on their system, and so they could potentially download it and compile it if they want, or potentially in the future, if we add that particular capability to our tech tree, then we could go back and do, the tech to HTML conversion and things like that. So
I see.
that's your question.
Thank you.
Thanks, David.
Yep.
Pablo?
Well, just to complement on David, it will be somewhat hard to verify that a text source that is being given does compile to a particular PDF if one cannot compile. There are many books which are complex enough, which are deposited in the arXiv in PDF format, and it would be completely impossible to compile it in LaTeX because of reasons like proprietary fonts and the complexities of the file itself. So it would be nice to ask the authors to, voluntarily provide the LaTeX source so that CONART can search. But it is a very laborious and verifying process. But I just want to say something about the previous discussion, which is the front. CONART also mentioned the front, which was for many years a very nice addition to the arXiv. Many mathematicians used the arXiv only via the front. And it would be extremely easy for the arXiv to integrate the functionality that the front introduced at UC Davis. It was managed by Greg Kupperberg, which was himself a member of the directory team at the arXiv, and integrating those functions. I mean, I understand it was taken down because of a security breach, a security flaw on the way that the two machines talk to each other. But integrating that in a single machine, it would be sort of not such a big task. And it would be a nice feature to pursue with the target of accessibility.
I'm taking notes.
Thank you.
Yeah, I may bring this up with Greg and see if we can do something.
Thank you.
I have a question, if I may. So just going back, I want to get into the details. So we heard that the LaTeX file is, at least some people are very happy if they've got the LaTeX file. How do you compare the accessibility of a LaTeX file to that of HTML? So how would it be read out? This is question for Shamsi, perhaps. Do you have any idea what? So what I'm saying is, I think you got my point.
Yeah. So the feedback that we got from users with a variety of disabilities is some people like the text source, like CONART, and they appreciate having the text source, and that works for them. And others do not like it. Others do not like reading the raw tech formulas and would prefer MathML, for example. So one thing that HTML will allow us to do is it'll give us some more flexibility in display. For example, if you are reading an HTML file, you get to a formula, we will have MathJax installed. The MathJax itself will actually give you options. You'll be able to look at the raw text source if you want, or read it as MathML. And there's other exciting ideas in the MathML space that will become available as they're more fleshed out, like math intent. So the HTML format will let us be flexible and will let us go back. Maybe in a couple of years, there's new ways to display math for screen readers, and we can go back and refactor and improve. So we're excited about the flexibility of HTML, and that's something that no static format can offer.
Okay.
Mhm.
So what? Just briefly, the sort of the if you summarize, what you want ideally is clean HTML with MathML, with math in MathML. Is that correct?
I think we want any semantic format. So like if the whole scientific world was like, we're going to give you great XML, that would be great. We don't insist on HTML, but HTML seems like what's achievable.
Yeah, I mean, HTML is the complex part. I mean, HTML and XML is sort of, similar thing. XML is more structured. The main part with arXiv is the mathematics, and XML, if XML has it in MathML, then that'll be viewed in HTML as well.
Right,
Okay.
right.
Thank you.
And Kelly has her hand raised.
Yeah, I just have a couple of simple questions. The first one being, if author submits something and does not provide the LaTeX, is the form that's given a PDF and that's it? Or is there another source file that's often given? Like, I'm guessing, like, I'm wondering if there's any Word. Like, can you submit a paper in Word? Okay.
There is some. You can submit your paper in Word, and David could speak to this in more detail. I don't know what percentage of papers are submitted in Word exactly, but I know it's small. Do you have any
It's
more?
small, very small.
Very small. Yeah.
No, I don't.
And
I
are
could
those
probably-
converted to LaTeX or no?
No, not to tech. No, the end goal is really, right now it's the PDF. It's to generate a PDF. And accessibility really wasn't on the agenda, 20, 30 years ago when these systems were first put in place. So we're bringing that in as one of our goals now.
Right. We do ask for the
I have one.
So I was just going to say, like, if we detect that the PDF was generated from tech, then we go back to the author and ask them to submit the source. That sometimes works. Actually works quite a bit. So.
Okay, that's great. I have one additional question. You mentioned in your presentation that you have, or the table that you shared in the chat, and you provided that in case there was somebody that couldn't see the figure. And I was wondering if that practice seen as, like, was that a user feedback thing where you learned to provide a table that provided the same information as a figure and people perceive that as being helpful? I guess I'm asking a leading question here because we have very large documents with a lot of figures, and I often get like, I'm like, oh, we don't need the table because we have the figure. And so, but does it work both ways in that, say, in your alternative text, that it would be helpful for somebody to have the linked table for the figures that are also represented as tables?
Yeah, so the user journey document that I shared was very much influenced by the feedback that we got from users with visual impairments or reading disabilities. So one of the relevant pieces of feedback that we got is that tables are really good. Tables are very accessible. And if data can be shared in table format, then do that. Another relevant feedback that we got is that oftentimes people will find that the paper is the barrier. The paper itself is the barrier to the real information behind it, the real research behind it that they want to get access to. So if you can share your raw data, that's good. Then people can sort of parse it and make sense of it in the way that works for them, where the way that you made sense of it might only work for somebody with a visual way of absorbing information. So that was another piece of information that was very influential on this user journey. The user journey has 2 tabs, and one of them is data. So the underlying qualitative data that we received is broken out into table format there, and that's what we use to create that chart. So we're including both, and that was very much influenced by the feedback that we got.
Are there any more questions for Shamsi?
I have one question that maybe it might be for Cournaer. So when you are reading the what do you hear when you're reading the LaTeX file? Do you listen to the do you hear \alpha \beta, or is it more user friendly than that?
I use VoiceOver on my Mac, and yes, he reads words and formulas, and I can verify character by character. But in fact, my field is geometry and topology and group theory. Well, there are no big formulas, maybe like in analysis or other areas. So really, it's great for me. LaTeX source is okay. I don't need HTML. I tried Majax or HTML, and I had always problems. It's not, the formulas are not always well spoken. But once again, with LaTeX source, it's perfect, at least for me. So please do not change this.
No, that of course the LaTeX will always be there. But I'm just trying to imagine if I
Yes.
was listening to a long formula, by the time it got to the middle, I've forgotten what was it. But you probably have a better sort of you can keep it in your head better than we can, because you know you trained to do that.
Oui. Once again, when I have a big formula, I analyze it character by character, but really everything is okay. It's fine for me.
Thank you.
Colette, I wonder if you would be interested in sharing your experiences with arXiv. I would love to interview you if you had time.
Oh yes, of course. Yes, no, but I am retired, so I have a lot of time.
Perfect.
Please contact me. My email is on my web page. And on my website, there are some information about how to use a VoiceOver for mathematicians. If you, well.
Sorry, Corna, do we have the website? What's your website?
So you type Michel Cornert, and it's page personnelle de Michel Cornert, and I have a link which is mathematics in the dark. Mathematics in the dark. Can you see it?
We'll be able to find it. We'll have no difficulty finding you.
Okay.
Thank you.
There we are. We have a link already.
Yeah, thank you so much.
So, is it time to swap roles, Shamsi?
I think so.
Okay, so I'll get ready to give my presentation. Would you like to be the MC for this?
Sure. How can I help?
Well, just
Watch for raised hands and things?
yeah.
Absolutely.
So this is the latest episode in using Git, which is Git is a source control system, version control system for programmers, and it's really interesting because it's a peer-to-peer content addressable store. Now, what that means, content addressable, means you store something according to what it contains rather than the name you give it. So if two things are stored at the same address, they are identical. And peer-to-peer means that no particular node in the network has any special value except in the way that other people treat it. So it's not as though there's a hereditary monarchy. It's somebody gets to be the hub because other people recognize them as the hub. So there's tremendous equality about things. And an example of this was that kernel.org, which holds the Linux archives, had to be closed down because there was a breach of security. And all the people developing Linux simply switched to the mirror that's hosted on GitHub, and it made no difference at all. And then when the kernel.org came back again, it switched back again. So there's a tremendous resilience there, which is similar, if you like, to the resilience that allows the internet to work. The internet is a tremendously reliable connection made out of rather unreliable components. You know, it sort of routes its way around damage. And that's part of what the Git does, is if you can't get it from one place, you can get it from another. So I'm going to start sharing my screen. God, sorry. It says my browser's preventing me sharing my screen, which is terrible. Sorry. Right. I'm going to try refreshing my page to see if I can't solve this problem. I'm going to disappear for a moment and hope I come back again.
This meeting is being recorded.
The joys of technology.
Here we go. I can do it. Okay, you should be seeing a window on the left with text in it. Okay,
Yep.
so am I sharing my screen? Yeah.
Yes.
Okay. So,
Jonathan,
yeah.
Can you take the browser window away because you have a double image being propagated? Yes.
Is that good?
Yes, that's better.
Okay. So let me just. So this is the page on the TechHow website, and the purpose of the TeX Macro Store is it's an alternative delivery mechanism for all the files you need to process a TeX document. And here I give an example of how it works. So TeX Macro Store is a location on the internet, and we use that as the name, and we can fetch from it the zref package. That's just one of the packages in LaTeX. It's the one at the end. And you notice there are two numbers in the tag there. The first number is the year of TeX Live, and the second is the version of ZRef in that year. So there's a naming system here that I've invented and can be changed if we want anything better. And if we do that, we get the package appearing and we store it locally. And here's an example of how we can use that locally stored package, which is we can, having got it, we can ask to produce a zip file. There's the name of the zip file. And in that zip file, we want the thing we just fetched. And we've now got a zip file, so we can unzip it, and I'll just list the files in it. And here we see that we get all the files in the zip file, all the files in the zref package. And the next thing is at the beginning here, git fetch TeX Macro Store. I'll expand this command a little bit for you. Git is the version control system. Fetch means get it from somewhere. The TeX Macro Store is the place to get it from. And we asked it to give us the thing that is tagged at this value here. And what I did here was I said to Git, add as a remote source something called TeX Macro Store and give it as a URL my macro store on GitHub. And here's an example of how it works, of the benefit of it, which is that the TeX macros in all the versions of TeX Live from 2010 to 2022 on disk occupy 4 GB, whereas the files, when Git stores them, occupies 210 megabytes, which is a 20-to-1 benefit. And there's two reasons for that. The one is it only keeps one copy of each of a file if it's identical. So if something doesn't change year from year to year, only one copy of that thing is stored. And the other thing is it compresses the stuff. Mostly it's duplication being removed that gives the tremendous scaling. So the benefit of this, one of the benefits, is that you can actually store hundreds of versions, all slightly different from each other, and check out the appropriate version you need for a particular paper. So to get a reproducible document, you create the document, and then you store the whole TeX tree that you use to create the document, and that becomes something that you can pass around. And because your TeX tree is very, very similar to somebody else's TeX tree, you only have to send out the differences. And that makes the whole thing rather efficient. I'm going to go under the hood, back behind the hood a little bit here. First of all, I'll show you how I created the TeX Macro Store, which is I installed TeX Live for all the years from 2010 to 2022 on my machine. So this is an installation of TeX Live from the DVD, and I haven't updated it. It's just from the DVD. And for each of those years, I store it in my original TeX Macro Store. So this is what this command does. And then I tag it. And the tag allows you to access the thing using the tag name. This is the same as the tag name we saw earlier. So I'm now going to show you something a bit different, which is a different way to build the TeX Macro Store. And this will, what's the word? Make it easier to understand what's going on. So here's one I prepared earlier, which I am now deleting. And with any luck, all of this will work quite straightforwardly. So I'm going to create an empty repository. There we are. There's an empty Git repository. And it's not completely empty. It's got a whole bunch of files in the .git folder. And all these things here are just templates that the thing gives. We'll explain what's really going on later, but essentially there's nothing here. So now I'm going to do something rather odd, which requires oh, sorry. Ah, there we go. Ah. Sorry, I'm making a big mess of this. What I've done is I've put something in a file. Now, what this something says is in this repository, when you ask to get something from this repository and you don't find it in the repository, have a look here. This is an alternate place to look. So this is like a backup store. And now this empty repository effectively has every object that is in the macro store that I've just highlighted. And I'm now also going to do something very odd, which is I'm going to copy a packed refs file to my Git repository. So if I do less.git packed ref, now what you see here should be very, very familiar. Well, the first column is long sequences of numbers, and the second column is the names of tags, refs, tags, and then the rest is just like we've seen before. So what this is saying is if you ask me for this object, if you ask me for this object, here's the address of it. So if you know the internet, you know that you have two sorts of addresses for websites. There's the www.archive.org, which is the human address. And then there's the dotted quad that is the internet address. And on the right-hand side here, we have the human name for it. And on the left-hand side, we have the computer name for it. So by those two acts, we've now managed to do what I've previously said, what I showed on the TeX website. So I'm now going to create the zref file. So I've just created that zip file, and if I unzip it and list it, there are all the files. So I'll go back to the website So on the website, I said, we can run this archive command and we'll get all the files out. And the way in order to get all the TeX Macro files onto your machine is to download one file, actually two files, which are the files in here, which is what Git calls a pack file. So you put this 210 megabyte download into your machine, into a special place, and you put the list of references into your machine in a special place, and now you have on demand every version of every package as macros that is stored in the big file that you downloaded. And with a certain amount of work, that could include every release of TeX Live, not just the annual releases, but the incremental releases. And with further work, it could include people's additional macros that they're actually using, and they can be put into the repository and made available in the same sort of way. So this is a tremendous simplification, and Git is a very powerful system that's widely used and widely supported. And so you get so much available for free. And it's a system that developers are familiar with. So I think I'll stop presenting at that point and see if there are any questions. How do I stop presenting? Oh, sorry. I know how to stop presenting. I've got to bring this horrible page back up. Oh, I stopped presenting now, haven't I?
Yes,
Yeah.
looks good.
Yeah. Okay, so I hope that was clear enough to give you the general idea. It's perhaps a bit technical, but
I love it. It's great, and I like how you've been evolving it since the last Git meeting that I attended.
so will you do me a great favor, David?
Mhm.
Which is, will you explain it to everybody else?
I guess I could try. I mean, so basically, you are creating an index of all the versions of specific packages such that the client can, well, I guess I'm not clear whether you would download all of them, but you can have this package on your system, and then you can create a local reference. And I'm not sure if that would be like, would that be similar to kind of the local tech trees that we do like at arXiv that would potentially link to specific packages? And so that's kind of my understanding. I mean, it seems like you could eventually be able to select any, I mean, you can select any of these packages for a particular submission. And I'm just thinking back to the last talk where you had these specific manifests for each paper, where you could have, my understanding is you could have like every paper using different versions of a particular package. So I may not be capturing that exactly, you know, how you intend it, but I'm probably embellishing it a little bit.
I think you've embellished it with something very important, which is why it might be useful to you. Whereas I've been focused on all the technical problems I've been trying to solve.
I've been your last Git presentation. It's kind of launched a bunch of ideas, and I mean I'd like this. I mean, the TeX Live folks, I would like to see them kind of look at what you're doing. But the issue is they're using SVN, and And I understand why they're doing that, because they've been using it for 100 years, and it's probably difficult kind of to shift. But I mean, I think there's some very good ideas here, and maybe someone else maybe the Git side of this could be someone else that maintains it. But I'm just tossing that out there. I'll let
Okay.
other people talk.
Let me recast what I've done in terms of what you've said, David, which is that with Git, you can put things into version control, and a TeX Live the TeX macros in TeX Live will occupy 50 megabytes, 100 megabytes for a whole tree, and over the course of 10 years, it's occupying, I think it's 210 megabytes, which is quite a lot if all you're doing is submitting a paper, which is 1 megabyte. 1 megabyte is a whole book in TeX. But there's this tremendous commonality. So what you can do is, instead of sending to the other person, your whole pantry, your whole kitchen, your whole store cupboard, you send them a shopping list.
Exactly.
And the shopping list will be zref package, such and such version.
Right.
Hyperref, such and such version.
Right.
My own special macros, particular version.
Mm-hmm.
And just knowing the numbers and the path to the tree which has that number, you can construct the reference to the whole tree. So all you have to do is you say, okay, so let's go to saying, I want to use this version of this package, this version of this package, this version of this package, this version of this package. Well, as long as the other person has got all the versions, you just have to say this version of this package, this version of the package. And Git provides you a way of condensing that information into a single number. And you send that number, and you tell the person, request this number if you want to compile my paper. And the Git on behalf of the other person will say, I'm going to request that number because I don't have it. And you'll say, okay, well, it's a tree, and here are the things immediately underneath it in the tree. Have you got any of those? And it says, well, I've got them all except for this one. So can you give me that one? So there's a bit of a negotiation going on, and you just get the things that you need. And Git was set up to do this very efficiently by the person that wrote Linux. So he's a smart chap. And it allows synchronization. It allows two people to have identical trees very, very quickly, very easily. That's really the point, is that I've got a tree on my machine. And if you and I, if I say to you, you'll find the answer to your question on page 57 of volume 3 of Encyclopedia Britannica 2007, you can immediately look that up. And Git does a similar thing for TeX macro packages. Does that help fit things together, David?
Yeah.
Yeah, if I can come in, I think it sounds great, a bit above my pay grade, but I think so. What you're doing, I think that you got the bit, you hit the nail on the head when you said instead of the shopping basket, it's the shopping list.
Yeah.
And the system that's the important thing. So it's the shopping list is small. You can just send it's a piece of paper, and someone else, Git, is getting all the shopping for you, right?
Yeah.
So
Right.
Thank you. So it's a great idea. You're saving a lot of space. One question I have is, Jonathan, is there any increase in speed or not? Obviously, you're saving space, and it's very elegant. If I'm typesetting something, is there any efficiency in is it speed efficiency or not? In
Okay,
typesetting.
I'll quickly talk about efficiency. Most of the time, the CPU is the quickest part of the machine, and the big struggle is feeding it quickly enough. The Git stores everything in a compressed format, and so the compressed stuff is sent to the CPU, which then expands it in no time at all, so that's quicker. There's a big difference between having 10 gigabytes of data on disk, and you're looking in that 10 gigabytes, and having 200 megabytes of data. That 200 megabytes can easily fit in RAM. So that makes it going from RAM rather than from disk. So it will go like blazes, I think, even though there's a certain amount of indirection involved, because you're confining the calculation to the high-speed memory.
Yeah. So sorry. So roughly speaking, you're fitting the whole of TeX Live in RAM, right?
You could do, yeah.
You could do, yeah, exactly. If you got a lot of RAM, it's just everything is at RAM. There's no yeah. That sounds. I can't fault that, although I'm trying, Jonathan.
Well, we got sort of. I got all on disk. It was 10 megabytes, 10 gigabytes, and on RAM it was 210 megabytes, 0.2 of a gigabyte. You know,
Right,
so it's just a tiny corner of a memory stick. The speed benefit would be enormous, and also if things are going over the network, it'll be enormous.
I see Kelly has her hand raised too.
Oh, sorry, Kelly. Thank you, Shamsi.
Okay, I guess I'm just trying to wrap my head around what's happening, and I'm wondering if this is a faster, more computer science version of like a Docker image, which is what I'm more familiar with.
Okay, let's go back. The Docker image is like a shopping list. A lot of the time, a Docker image, I'm not sure. There's two sides of it. But let's put that to one side. I'll respond in something you're familiar with, which is TinyTeX as it's used in R Markdown. Yeah. So this approach allows you to roll your own and freeze your own distribution that just has the things that you need. So this will convert TinyTeX just into a recipe. These are the packages. And you just list the packages that comprise TinyTeX. And you say, oh, no, I want these versions. And it will create for you a Git pack file, which is the thing that was in the alternate sources. The Git pack file has got all the data in a compressed form. So you can create a recipe that will create a Git pack file that is the thing that you use when you use a GitHub action. It can be the thing you use to produce. So it will allow you to build a custom thing that you install into your Docker image. It's not part of the Docker image. You just say it's one of the parameters of the Docker image, and it gets put in there, and it will give you the tech that you need and nothing else. So you're smiling.
Yeah, that was very helpful. And it would also be great for someone like me that has problems with people having their own installs and on their local machine and not understanding the background behind that. So if there's a way that we can quickly install all the stuff that we need, like I'm familiar with TinyTeX, having all of the packages that you already need rather than trying to compile and then failing and needing like to look at that failed, log message which is what TinyTeX does. And so it goes to the log message and then tries to look up all of the packages that you need and then only install those ones. But if you can just do it from the get-go and then have it where it's quick enough and small enough to run in a GitHub action, which then can compile what you're trying to write in the cloud. And then to users that don't want to know all of this stuff, they just want their PDF, then it could be distributed as an artifact very easily. So thank you for your explanation.
Right. So to go back to what Carvey said is that we're dealing with shopping lists. We're not dealing with grocery trolleys. So you have a big store that's got one copy of everything, or pretty much one copy of everything, and you give it a shopping list, and they'll say, "Yeah, I've got everything in this list. What do you want me to do?" And you can say, "Oh, what I'd like you to do is create me a zip file containing just the things I asked for." Or you can say,
yeah, it's like,
or
I was
right.
just going to say that it's like Walmart now, where you can just send your order in online and then you go in through the drive-through and pick everything up.
Yeah.
Which started with COVID.
Yeah, and for David Fielding, it can not only produce zip files, it can produce tire archives. And it can not only write it to a file, but it can write it to a pipe. So you put a tire extract at the other end of the pipe, and what you've got is home delivery. You just say, I want this thing to go here, and it will just populate that area with exactly the files you need for that particular object.
Right.
And it's a fairly quick operation. So in some situations, you can say, okay, we're not going to keep it. We'll just populate, do the job, throw it away. If the next job is the same, we'll do it the same.
Right. And I'm shopping list manifest. I was thinking what Kavi was saying, like, if I send you my manifest and you don't have those packages, the only delay is just grabbing them. And after the first time you've downloaded them, that's probably the major cost that you're going to incur. And then after that, you're all set.
Or you can say, I like to keep a full larder. That's what we call it in Britain, a larder. I'm going to make sure I'm well stocked, and I'm going to download all this stuff the moment it comes out, even if I'm not going to use it for another month or 2 months.
Do that, yeah.
Yeah. I'm going to go to Shamsi, which is, if we can create a standard environment that includes not only LaTeX, but all the conversions to XML, HTML, and the incorporation of MathJax, then that would be really good, because you'd like the archive processing to be done using exactly the same resources, exactly the same inputs as the author is using, or the other way around. You want the author to use exactly the same as what you've got. And because the archive is the archive, you have to deal with papers that are 20 years old. So you have to keep all these different versions. And the thing about Git as a form of version control is it never forgets anything. It keeps every version of every file unless you make some special effort to get rid of it. So you get all these benefits because Git was asked to solve a problem that programmers need. They need reproducibility of results, and you need reproducibility of results. And I'm simply using Git because it's the best technology. And I'm not using Git as a version control system. I've not, in all of this, I've not done any commits, which is what you're supposed to do with Git. You have commits and history of commits and log messages and all that. No, all you've got is a bunch of trees. You've got trees on disk, or trees that can be put on disk, and each tree on disk has got a number, which is like a fingerprint. And one of the pieces of code that I showed you at the beginning created all of those trees. And for each of those trees, it said, here's the number that you've got. So once you understand that every piece of data you deal with can be given a number, which is a bit like a social security number, but rather longer. And if two things, it takes an astronomical amount of time to create two objects that have the same number. So if they do have the same number, you can be pretty sure they're the same. Everybody relies on that.
Can I ask, firstly, we've done fantastically well with the grocery analogies, and they're absolutely perfect. And you came up with the larder, fantastic. So I'm beginning to understand that. On a question for arXiv, just this came up. Do you have, for all the old TeX files, do you have all the files that we're used to compile them?
Yeah, so we have retained all of the TeX trees going back as far. I mean, when arXiv started, TeX source was received via email and it wasn't compiled. So there's a point where there's some questions there in terms of compiling, but we go back to TeX 2, TeX 3, TeX Live 9, 11, 16, and 20. We're going to be doing 22 soon. So we have retained all of these trees, and we can recompile these papers. So that's why with the accessibility that we're going to take advantage of existing tools, take the TeX source and do these conversions. And but in terms of having these packages, yes, we do. And that's why I'm so interested in this. It's because one issue with arXiv is that we tend to freeze our releases, because I mean, I've experienced this where you pull in a package that breaks everything, and it changes the look of an article, and we can't have that, right? So we basically do the upgrade. We do some minor bug fixes, but then we basically freeze it so that we're not changing articles. And so I like this idea. I mean, there'd be a lot of work to do to get this to happen, but to be able to do this, being able to specify a particular package and not worry about it anymore, not worrying, so I'm kind of excited.
I agree. I think this could apply from just thinking about it. You've got millions and millions of files. A lot of them are duplicated in different directories. So with a one-time conversion, you can have just each one has the address. Actually, you've got a huge amount because there's so many duplicated as well, right? You've probably got thousands of the same file in different folders. I don't know how you keep them.
Yeah.
Because otherwise it would be difficult. So what you've got, it's I don't know how you
Let me give you a different view of it, which is 90% of your data, in some sense, 90% of your data will be stored in these pack files, and the pack files sort of top out at 2 gigabytes. So you have 50 pack files, each of which contains 2 gigabytes. Well, you make a backup of all of those pack files once, and then you make sure that those pack files are never changed. So none of the data that's already stored in the pack files do you need to back up, because you've already backed it up and it hasn't changed. That's another way of looking at how it goes, is that the whole process of backing up your disk installation, you only have to back up the things that aren't in the pack files. I think the thing that's most exciting in terms of what Shamsi is talking about is if we can get the conversion tools that authors want to use, or that the arXiv wants to use, into such a setting, then we have a good starting point for achieving reproducibility of results. So that when the author downloads a package from somewhere that contains the LaTeX to HTML tools, and there's a high degree of confidence that when it's submitted to the arXiv, the LaTeX to HTML tools are identical with their inputs and so identical with their outputs. I think that's, and we take that for granted with TeX, but David knows that it's actually hard work sometimes when there are incremental changes in packages. And the question of accessibility is not a question of, oh, well, there's going to be an incremental change every 6 months. You're once the project gets going, you'll be wanting to introduce new versions of the tools as they come out quite quickly, I think.
That sounds enormously beneficial for authors, and something that we've heard from authors outside of the accessibility conversation as well, that they want to be able to reproduce locally whatever archive is using.
Would perhaps some sort of technical conversations outside of this tech hour might be quite helpful, David?
Yeah. I mean, there's the issue of the tech packages, and then you've got all the binaries too that also do change things. So
Yeah, there's not only the binaries, but there's also the format files, which they're binaries, they're not executable binaries, so they have to be regenerated. I'm thinking that you, me, and Kelly. Now, Kelly's not a big wheel, but R is a big wheel. And creating something, Tiny Tech is a great innovation. So repackaging everything so that one can use a Git version of the tech store the tech macros in Git and get the benefits of that, and some proofs of concept of that would actually take things forward quite a bit, I think. And it would also mean that I wouldn't have to give technical explanations. I could just say, look at this, look at this, look at this. Isn't this what you want to have happen?
So a quick question. So you're seeing the resolution. So this will all happen outside of the current sort of Tech Live environment. You'd see the manifests, updating your local Git setup. That would happen first. I mean, I was thinking that maybe Tech Live would have to play along with the scheme.
Well, there'll be a bit of, I think, like in America, it's called jury rigging, where you don't quite do things the proper way, but you get the thing to work. So one of the important things Tech Live does is it does a sort of curation of content. It takes the stuff from CTAN and puts it into Tech Live. So one needs a tech installation somewhere that's updated regularly. And the only purpose of that is to put stuff into Git. So all the incremental changes go into Git. And this is a bit like the old days where Metal was the only way to typeset. So you typeset your stuff in Metal, you create one very nice image, and then you use photography to guess a litho plate, and you print off the litho plate. It sounds bonkers, but it was done. So the transitional stage is to use Tech Live as an installation, not for typesetting, but to simply update the Git repository. And then so essentially you put a Git repository between the Tech Live archive, the Tech Live update, and the user machine. And instead of Tech Live updating the user machine, Git updates the user machine, but Tech Live does all the stuff like the building of format files. So it would be a sort of a bit like that car that the Ford automobile worker in Johnny Cash's song spoke about, where he stole the car from the works one part at a time. Do you know that song? Can't remember.
Yeah, I know that song. I know that song.
Yeah. So this part of it's from a 1956 car, and this car's from a 96. It'll just be a sort of whole mixture of technologies, but it works. It's like sort of sending something by fax and then using an OCR at the end. But getting the concept clear and getting it sort of provably useful is, I think, close to the next step. And I can share with you the scripts I did for populate. You can reproduce what I've done. It's not difficult. It's sort of 200 lines of Python code, and you can do exactly the same as what I've done. And then we're on equality. And you and I should calculate exactly the same numbers from exactly the same inputs. You know, I say that the TeX Live 2022 macros for the TeX tree should be this number, and you should do the same calculation. You should get exactly the same number. And if you do, then we don't have to check that our files are identical because they've got the same number. Shamsi, you're the host. Your job now is to shut me up and to ask everybody, thank everybody, and they can stay if they want to, but I think we ought to bring it to a close. So up to you to close, please.
That sounds good. We've gone a little bit over, but not as much as we sometimes do. That was fascinating. Jonathan, thank you again for bringing us all together for these wonderful conversations.
Yeah, can I thank Jonathan and also Shamsi and everyone else? It's been, you know, I'm trying to get rid of this habit, but I just can't drop it. I'm afraid I'm hooked. I haven't been able to come last few weeks for different reasons, but thank you.
You were at the Frankfurt Book Fair, you said.
I was, well, yeah.
Well, you could tell us about that sometime. That would be nice.
Happy to share. Yeah.
Yeah, thank you so much, everybody. Thank you for your questions earlier. And yeah, great meeting.
Thank you.
Thank you very much.
Till next time.
Next time.